All right, so the first lesson in this graphical analysis unit is on graphing linear inequalities in two variables. All right, um, so basically what we're going to be doing is we're going to be just graphing inequalities. So we are going to be working with lines for this lesson. Okay, so you guys did spend quite a bit of time last year in Math 10 going through linear functions, equations, graphs of lines, and that kind of stuff. So you guys may recall the formula for a line is y equals mx plus b, where the m stands for the m is the slope, and the b here is the y-intercept. Okay, so I'm going to spend a little bit of time, I guess, reviewing because we've got to be able to graph these lines in order to graph these linear, what they call inequalities. So basically with this lesson, what we're going to be doing is, we're going to be graphing these linear inequalities. First thing we're going to do is graph the corresponding line. And then there's just kind of like an added step when it comes to inequalities. All right? So let's just jump into the first example here. So we're going to graph y is less than negative 2x plus 3. Okay, so this is the inequality that we're going to be graphing. The reason it's called an inequality is because of this sign here. Okay, so what you'll notice is that is not a equal sign, right? But that's what you were doing last year. For this lesson here, just kind of like an added step with this inequalities at the end. All right. So, but first step is still the same. So I'm just going to write that out. Step 1 is we're going to graph the corresponding line. Okay, so for in this case, instead of y is less than, or as an equal sign, what I'm going to do here is just change it to an equal sign. Okay, so we're going to graph y equals negative 2x plus 3. All right, so so two things we need to know when we're graphing a line is basically the slope and the y-intercept, or the location. All right, so in this case here, we have a slope is equal to negative 2, and our y-intercept is at positive 3. Okay, so I guess more specifically, it'd be the point 0, 3. All right, so the slope itself, just going to use a green. The slope here is equal to negative 2. Now, what we want to do here is actually maybe write it as a fraction. So that's negative 2 over 1. And this gives us the rise over the run. So, so in order to graph this line, what we're going to do is actually we're going to start off with the y-intercept. So that'll give us like the location or a point that we can use that is on the line itself. All right, so since the y-intercept is 3 on the grid here, I'm just going to plot a point here along the y-axis at positive 3. Okay, so this is the point where the line crosses the y-axis. Okay, so that's the y-intercept. Next up, we want to find another point. So the slope in this case is negative 2 over 1. Okay. Now, if you recall, negative slope. So if the slope is negative, your line is going to go in this direction. Okay, down as you go to the right. Just as a side here, if it was a positive slope, it'd go in the other direction. Okay, so in this case, for every since it's negative 2, for every 2 units we go down from here, from the y-intercept, so I'm going to go down unit. I'm going to go across 1. Okay, so the rise is 2, run is 1, and we want to go in the negative direction. Now, if we continue that on, so if I go down to here and over 1, down 2 over 1, what you'll notice is that the points will line up as we in a straight line, okay, because that's our slope is negative 2. Now, from the y-intercept as well, I can go up 2 and then left 1, up 2, left 1, and so on, just to create this line. Okay, so these are more than enough points to draw this line out, right? Okay, so now our next step here is to draw in the line, but however, there's this kind of a special case here. So step 2, what I'm going to do here is draw the line. Now, if it is a strict inequality, so if your inequalities are like this, you're going to have a dotted line or a dashed line. If it's less than or equal to or greater than or equal to, so when there's an equal sign involved, it's going to have to be a solid line. All right, so in this case, when I'm drawing this in, you'll notice that the inequality itself was a strict inequality. Okay, so this means that we're going to have to draw it in with a dotted line. All right, so rather than drawing in a solid line, I'm just going to draw a dotted line. Do the best I can here. So it's going to go with something like this. All right. So that's one of the differences when you're graphing these inequalities, is that to notice or take into account the whether it's a strict or not strict inequality. Okay. So again, if it's a strict inequality, that means there's no equal sign underneath. It'd be a dotted line. If it's a solid line, it's going to have the less than or equal to or greater than or equal to. All right. So, and we're not done yet. So our next step here. Actually, you know what I'm going to do here? Just a sec, guys. Just going to make a little more space. Move the next example down to the next page. All right, so let's scroll this back. Okay, so we're not quite done yet. We've drawn in the line. Now what we need to do is shade in what we call the true region. Okay, so what this line does here is it actually splits the grid into 2 pieces, right? One on the left, one on the right side. One of these sides is what they call the true region. The other side will be the false region. So one side will be shaded in, the other side will not. So our next step here is we're going to, so step 3 is we're going to shade in and what I'll put in quotations here is the true region. Okay, and I'll explain what I mean by that. So basically what we're going to do here is we're going to take a point that's not on the line, and we're going to test whether the inequality, the original equality here, is true or false. Okay, so our inequality again was y is less than negative 2x plus 3. And what we want to do is we want to pick any point, any random point that is actually not on the line. Now, if you think about it, right, the easiest point to plug in probably is this point right here, 0, 0. Okay, so that's the point I'm going to choose to plug in. So choose right here. All right, so I'm going to test with the point 0, 0. Now it's important that you choose a point that's not actually on the line, right? So so we cannot actually use a point that's on the line. You've got to use a point that's not on line. So 0, 0 is probably the easiest one to plug in. So if I plug in 0, 0, and for the y is 0, and I got a less than negative 2 times, and then for the x, I'm going to plug in 0, because that's my x and y, 0, 0, plus 3. And I'm just going to work this out on the left side. It stays at 0. On the right side here, I got negative 2 times 0 is 0. 0 plus 3. So 0 is less than 3. All right. So now what we're going to do is we want to check whether this statement is true. Now in this case, 0 is less than 3. So what that means is this is true. And what that implies is that the point we chose, which was 0, 0, is in the shaded region. So what we're going to do to finish this graph off is what I need to do here is I need to shade in the side containing 0, 0. Okay, so in this case, it would be this side over here. So this would be shaded in. Right, because the point 0, 0 here, as when we plugged it into the inequality, it turned out to be true. Okay. All right, so I chose 0, 0, but I chose 0, 0. However, any point that you choose here, so for instance, -5, I don't know, -5, 2, if I chose that one randomly, plugged it in for X and Y, I'm going to get a true statement as well. All right. So any point that you choose that's on this side of the boundary line, what we'll call the boundary line, no matter what point you choose, it'll always be true. And conversely, if I chose a point on the other side, so the non-shaded region, no matter what point I choose, if I plug it in for X and Y, it's going to be false. Okay, so the true region is the shaded region. Yeah, and as long as you graph the line correctly, right? So the line itself, what it does is it creates a boundary, and it splits the graph grid into two pieces. Right? So one side is going to be true, one side is going to be false. And again, it doesn't matter what point you choose. In the shaded region, it'll always be true, and any point you choose that's not in the shaded region should be false when you test it. So that's what these inequalities are. So the graph of these are basically you're graphing regions, right? Not just lines. All right, cool. So I'm just going to go on to the next one here. Right, so this time we're going to graph 3x plus 2y is greater than or equal to 12. Actually, again, just going to give me one sec here. It's going to create a little bit more space for us. Example 3 down here. Okay. All right. So next up, we have 3x plus 2y is greater than or equal to 12. Now, what you'll notice with this example is that the line itself is in a different form. So this is still a graph of a line, right? So if I was to graph the corresponding line would be 3x plus 2y equals 12. All right, so this is the line I want to graph. So what you could do here, or what we want to do here, is there's two ways to actually graph this thing. So I'm going to show you one way is to kind of change this to slope-intercept form. All right, so to do that, what we need to do here is we need to isolate the y. Okay, so in other words, this 3x, we're going to have to move over to the other side. And that would be, so when I do that, the next line would look like this. I'd have 2y equals negative 3x. And so when you take any term, move it to the other side, you're switching the sign here. So that's negative 3x. And we also have the plus 12 here. Right. And then once we've done that, we can divide through by 2. So that this 2 cancels with this, and then we've isolated the y. So if we were to simplify this, we've got y equals negative 3 over 2x plus 6. Okay, so 12 divided by 2 is 6. All right, so now from here we can pick out the slope and y-intercept. So my slope is negative 3 over 2. And the y-intercept here is at positive 6. All right, so I'm going to start off at 6 here. And again, negative 3 over 2, so we know the line is going to go in the negative direction, so down to the right. This is, again, your rise over your run. Okay, so I'm going to go down 3 units and then to the right 2. So from 6 here, I'll go down 3 and right 2. So this point, so down 3, right 2, this point is going to be on the line. I'll go down 3 and right 2 again. Let's do it a few more times. Down 3 and right 2, and all the points should line up in a line. I can also go up 3 and left 2. Cool. All right, so there's the line. Now what we want to do is we want to figure out whether it's a dotted line or a solid line. So since this is not a strict inequality, so in other words, it has the equal sign underneath, this has to be a solid line. All right, so with a solid line, I'm going to draw this in. And I'm kind of freehanding it, so it might not be the straightest. But when you draw your lines, yeah, it's a good idea to have like a ruler or something with a straight edge, maybe your debit card or something. Something just to draw the lines in. Right, so something like that. All right, so that's supposed to be a solid line. because it's, again, not a strict inequality. All right. Now, before I actually, you know what, let's just finish this off. All right, so next up, just like we did in the previous example, we want to test it. And again, I'm going to test it with a 0.00, since 00 is probably the easiest point to plug in as well. It's not on the line. So 00 is not on the line, so I can use it. So if I test it with 00, just get two different colors here. I'm going to have 3 times 0 plus 2 times 0 is greater than or equal to 12. All right, so again, what I did here is I took the 0.00 and plugged it in here for the x and the y. So the zeros disappeared, but not sure what happened there. But anyways. All right. So not sure. Sorry guys, 1 sec. Put that screen back up. All right. So as I plugged in 00, if we work this out, you'll notice that this whole left-hand side is 3 times 0 is 0. So 0 plus 0 is greater than or equal to 12. 0 is greater than or equal to 12, which is false. All right, so this time we get a false statement. So what that means is that the point 00 is not in the shaded region. All right, so since 00 is not in the shaded region, so this point here is not in the shaded region, that means that we have to shade in the other side. Okay, so that means that the true region would be the region not containing 00. So that's this side over here. So we would shade in this side over here. And again, any point that you choose over here in the shaded region, when you plug it in for x and y into the inequality, it'll always be true. And likewise, any point that you choose over here that's not in the shaded region, plug it in for x and y, it'll always be false. Okay, so again, so when you're graphing inequalities, you're graphing regions. So you need to shade this in. Okay. Now, what I'm going to do here is actually show you kind of a different way, a quicker way perhaps, to graph this line. So I'm going to kind of go back here. We isolated slope-intercept form. The other way, so another way to graph, maybe I'll write it up here in red. Other way to graph 3x plus 2y equals 12 is that we can actually just leave it in this form and basically find the two intercepts. All right. So the x-intercept, get the x-intercept, you would plug in 0 for y, right? So what you would end up here with is 3x plus 2 times 0 equals 12. Well, if I plug in 0 for y and solve for x, 2 times 0 is 0. So it's as if this thing is, this term isn't there. Right? And now if you solve the resulting equation, 3x equals 12, you would divide both sides by 3. Therefore, the x-intercept is 4. And what you find here is that, yes, the x-intercept here happens to be 4 when we graphed it with the slope-intercept form. Right? And likewise, we can do the y-intercept as well. So if I want to find the y-intercept, I'm going to plug in 0 for x. So basically what happens is that 3 times 0 plus 2y equals 12. Well, this term here is 0. So then you're going to solve 2y equals 12, divide both sides by 2, so you got y equals 6. That's your y-intercept, which happens to be right there. All right, so, and that's all you need, right? You only need 2 points to graph a line. Okay, so so once you get these 2 points, you can just connect them up with the ruler, straight edge, it'll draw that line in for you. All right, so basically, yeah, whenever it's in this form here, where you have the x and y's on one side, you can change it to slope-intercept form like we did originally, or you can find the two intercepts, plot those, and then connect those up. So just another way of graphing this line, or perhaps a quicker way than isolating the y. Cool. All right, so on to the next example. Next one here, we want to graph y is less than 2. All right, so this here, you notice is different from the previous two because we don't have any x variables. All right, so however, the steps are pretty much still the same. All right? What we want to do here is we want to graph corresponding line, which is y equals 2. All right, so I'm just going to explain what y equals 2 means. Right? Basically, this is all the points with a y coordinate of 2. All right, so for example, I don't know, 1, 2 would be on this line. -3, 2 is also on the line. 7, 2, 15, 2, -5, 2. All right, so notice, so all these points here are on this line, right? So in the line itself, y equals 2 is basically, when we plot all the points. Now, it's impossible to plot all the points, but what I'm going to do here is just kind of show you what's going to happen here. So let me just grab a pen here. All right, so 1, 2 is right. -3, 2 is right there. 7, 2. 15, 2, it's off the grid. -5, 2. All right, so what do all these points have in common? Well, if you see here, if I connect these points up, it's going to create a horizontal line at 2 for my y variable. So, so basically, we're going to get this. Oops, you guys notice that I just did made an error. All right. So let me spot that already. Is before I drew in that line, I had to take into account whether it was a strict or not strict inequality. Well, this here is a strict inequality. That means it's a dotted line. Okay, so so instead of, or dashed line, instead of drawing in a solid line, we're drawing a dotted or dashed line. All right, so anyways, this horizontal line here, so whenever you have y equals a number, it's always going to be a horizontal line at that number. So y equals a number, this is always going to be a horizontal line. All right, so now we can also we need to figure out which side to shade in. All right, so this says y is less than 2. So intuitively, we know all the points that are where the y values are less than 2 are over here. We can just go ahead and shade this in. That would be it. All right, that's the correct answer. Now, if you want to be kind of like consistent with the previous example, you can also test, right? So we can also test with 0, 0. If you'd like. Well, for this here, y is less than 2. There's no x to plug in. Which is fine. Basically, we're just going to take this y coordinate and plug it in for this y. So we got y is less than, 0 is less than 2, which is true. All right, so that means that yes, the point 0, 0 is in the shaded region, which is again below 2. Or intuitively, you might be able to just read it off and just realize, yeah, y is less than 2. Well, that's got to be below 2. So this is the region we'd shade in. All right, cool. And just kind of like a converse example here as the last one. This time instead of y, I have x, right? So you can imagine instead, if it's x instead of y, we're going to draw in a vertical line at -1. Right? So again, and just kind of be, for example, the points, -1, 0, -1, 3, -1, -5. I was about to say, I was going to say 5, but wrote 4. So anyways, these points here all have an x coordinate of -1. Okay, so that would be, again, -1, 0, -1, 3, -1, -4. All right, what you see here is all these points will line up in a vertical. line. Okay, and again, I'm going to check my inequality. So this is a solid line. So so the line x equals -1 going to be this line here. And again, to figure out which side to shade in, we can just read it. Right? It says x is less than or equal to -1. So being less than -1 would be on the left side here. So this is the side that would get shaded in. Now, if it helps, just to be a little bit more clear, you can also take a point and test it. So we can test it with 0, 0. Now, when we plug it in 0, 0, there's no y to plug in. So we're just going to plug in the x of 0. Get 0 is less than or equal to -1, which is 0 is not less than -1. So this is false. All right. So again, this point here, 0, 0, will not be in the shaded region. If we test it, so it's going to be less than sign. All right, guys. So that's yeah. So that's linear inequality. So again, just scrolling back, just a little recap here. Yeah, you will be graphing the line initially, and then just kind of like the added step is to take a point that's not on line. Traditionally, 0, 0 works the best. Plug it in for x and y and see whether it's true or false. All right. If it's true, then you shade in the side with 0, 0, or the point that you tested with. If it's false, you shade in the other side, not containing the point that you tested with. All right, cool, guys. So hopefully that makes sense. Yeah, that's it. Ciao.